All right, welcome back. Day 4, classifying triangles, talking about triangles. So we'll get right into it. This first one, and all of them, we're thinking about what type of angle, and then what about the sides? Are there any equal, congruent sides? Might be kind of hard to see here, I know, but this is a 90. Okay, so that, even though there's not a box right there, right angle, we should know it's a right angle. So this right here, we could say is right. And then let's think about the sides. We've got those two marks over there telling us that there are two congruent or equal sides. So it's a right isosceles triangle, okay? Also notice 45-degree angles. I know this is talking about the angles, but that is part of why these two sides are equal to each other. This angle 45 creating this side is the same as this angle of 45 creating this side. The angles and the side lengths are very much connected with each other. Moving over here, looking at this one, a little bit funky, a lot going on. We only see one number right here, 60 degrees, and then these two are equal to each other. That's a little tricky for sure, but we'll talk later about how many degrees there are inside of a triangle. These are all 60. Okay, they all have to be 60. They're not 90, they're less than 90. And we should be able to see that none of these angles is open up 90 degrees. It's definitely a cute little triangle there. And yeah, the side lengths, we see 1, 2, 3 sides are all equal to each other. We're going to call that equilateral. Okay, equilateral. You know what? I could even slap on here one extra one. Again, we haven't talked yet about the angles in a triangle, the total of them. But if all of these are 60, like I said, they must be equiangular. And I had mentioned before, equilateral has to be equiangular. Some books, some tests are going to call this just acute equilateral. Some will call it equiangular equilateral. Some might just say one of these two words right here. You should know it's all of these things if that's the case. Okay, checking out this last one. Again, I know it's a little hard to see, but we've got 100 degrees right there. So we are knowing, hopefully, that that is larger than 90. It's 100. So what kind of angle? Obtuse. All right, we're focused on whether one of the angles is 90 degrees, in this case, greater than 90 degrees, or if all of the angles are less than 90 degrees, in which case it would be acute. All right, this one, obtuse, and then that's the angle situation. Now we're thinking about the sides. Oh, boom, boom, those two are equal to each other. The two sides, isosceles, obtuse, isosceles, wonderfulness. Okay, we are gonna go on a journey down here to the bottom left, where we see another triangle. And if I didn't mention this already, I don't think I did. This is slide 27. Okay, this is part of what you were supposed to do yesterday in class, these problems. If you're like, oh, I can't see the numbers, go to the slides. You'll be able to figure it out. All right, I'm not seeing a number for this, but I see that little right angle box. It is a right. Okay, and then these other ones, I don't see that any of the other sides are equal to each other. We would say it's scalene, okay? And it is worth noting, taking this to the next level, none of the angles are equal to each other. 30, 60, 90. That is why none of the sides are equal to each other. But for right now, just focused on, do we have any angle that's 90 degrees? Yep. So it's right. And then do we have 2 or 3 sides that are equal to each other? No. So it's scalene. All right, bottom middle, we're checking this out. The angles, any of them 90 or more? No, so it must be acute. And are any of the sides equal to each other? I don't see the marks, and I know the angles don't equal each other. So again, this is a scalene situation, acute scalene. Checking out this last one. We've got 120 degrees. That is larger than 90. So it is obtuse. All right, isosceles because two of the oh no, that's not the same. 35 and 25, they're not equal to each other. And more importantly, I don't see any markings saying that two sides are equal to each other. So another one where the side lengths are all random. Lengths, scalene. This is obtuse scalene. Okay, so we're going to move on here. And we're going to talk a little bit more about the angles inside of a triangle. Okay, as I'm pulling this off, though, we'll have a short little conversation. Like it's the classroom. A little teacher talk here for you. First off, I just want to say that the 7th grade math students doing a really good job. I mean, this is unprecedented, us doing school like this. Totally new, of course, for everybody. And most everybody's just doing a really good job of getting onto the Google Classroom, watching these videos. If you're watching this right now, then yes, good job. You're watching a video. The notes. Make sure that you're going through the notes. Those are really helpful to people too. A lot of times we're doing similar stuff in the videos, but just having more a sense of going at your own pace, I think, on the notes and looking at those visuals can help. Perhaps most importantly, though, email me your questions. And I know I've had some people who are like, I'm just not getting this. This is tricky stuff. Okay, sure. Yes, I agree. So that's starting the conversation. Just like I say in class. Let's try to go more specific from there. Okay. What is it? Can you pause like at the moment in this video where you're just like, look, I don't get what he said. And then try to figure out what your sentence might be. Let's come up with some way to get me to focus on what you're not understanding. Maybe you're saying, slide 27, this problem. Or how did you get this number when we went from the first step to the second step? Something like that will help us get a conversation going, and I should be able to figure out, how to help you out. Another thing that I've been doing a little bit with some students, and I know some other teachers have as well, the Google Meet. That's definitely an option. I'm able to do video conferencing with students. We just need to set up a time. So again, going through the email, if I'm not able to answer your questions on the email, or you just need some more practice, email me and we'll set up a time to do a Google Meet. But really good job so far, everybody. So trying to understand the angles within a triangle. We know that there's 3 angles in a triangle. But what does it add up to? I know a lot of people already did the lesson from yesterday. You get it. But if we are going through here and chopping this up, why would I chop this up? Well, so that we can focus really just on the angles. The angles, not so much the side lengths, but the angles here. If I were to do that and take this triangle, break it apart into the amount of space filled up by the 3 angles, I might be able to go like this. Might take this one, A, slide it over here. Let's see if this works, Mr. Fessenden. And yeah. Oh, maybe I get my tape out. Yeah, the tape is out. Boom, boom, boom. See if this works. And voila. I think a lot of people are seeing where this is going already. But it is just nice to see things click into place here. Yep. So yeah, those 3 angles coming together to create a straight line. We talked about that last week. It was usually 2 angles creating a straight line, but what would we call those? Supplementary, okay? Angles that add up to 180, above a line, which we're thinking all the way around the circle is 360, so half of that is 180. Yeah, these 3 angles add up to equal 180. So that's really what the next type of problem is all about, using the angle triangle sum theorem to figure out the missing angle. I believe this was slide 40. Problem number 1 is in the slides. That's done for you already. Maybe you can see these numbers a little bit better. If not, you're on slide 40. So the full-on technical way of using the formula to get our answer would be writing this out. These 3 angles in a triangle add up to 180, okay? So now I should just go through and replace these A, B's, and C's. 35, 110 plus n equals 180. Some people are at home like, you don't have to do all that. I know the shortcut. Cool. Awesome. Good for you. So if I add these two together, I'm getting a 5 there and a 4 and a 1 plus n equals 180. Okay. I like for you guys to set it up and do it this way at least a few times because that's reminding us of a few things. How to use a formula, how to substitute numbers into a formula, and then how to do some algebra type stuff, all right? Solving equations, combine like terms. 35 and 110 combine to make 145. And then how do we get the variable all by itself? Opposite operations. So it's really like we're putting some geometry type stuff, angles of triangles, together with some algebra stuff, opposite operations to solve for the variable, solve for the missing piece right here. Okay, what are we gonna have? 35 right there. Yep, I'll put a little degree sign. If you're like, wait, what's going on here? Oh yeah, we would go like that basically to get this. That's not 350. That's 35 with a little degree symbol right there. So that's how we could do it for that one. All right, for the next one, maybe we're getting a little bit trickier. And I know some people are already just like, I got this. But that last one, there's the last one on the homework that you either really struggle with it, or if you didn't, you probably didn't realize that you should have struggled a little bit with it. So this next one, maybe I'll show you guys a shortcut, a little bit of a shortcut here. Yeah, so basically we are adding these two numbers together, all right? We're adding 57 plus 54. Okay, 11, 10, 11. Is that right? Yeah, I think so. 111, you add those together, and then you take 180 and subtract what you got from adding the other two. You subtract that from 180, and you'll get your answer, okay? Bit of a shortcut here. 69 degrees. So the shortcut, realizing that if we had set up the formula, plugged in the numbers, when we combine like terms, that's just us adding these two angles. And then the opposite operations is subtracting that to 180 so we can find that missing number right there. Okay, the last one is definitely a little bit funky, a little bit tricky. So let's check it out now. We've got H's, we've got H minus 90s, all sorts of craziness. And there it is right here. So yeah, let's put that right on top. Wonderful. So for this one, we're looking at it. We're like, okay, and I got a lot of emails from people, good emails, like, what do we do with the H minus 90? What is that? That's just weird. So on one like this, I would definitely take my time and think like, I'm not sure how this is going to work out. But while I'm thinking, I can set this up and I can plug things in here. And this is a good time when setting up the formula, doing it this way really helps. That is an H plus, I'll put this in parentheses, H minus 90 equals 180. I noticed doing the IXL myself a lot of times, I was going quickly and I would just like forget that this was 180 and think it was 90 because those two numbers go together a lot. Okay, so it's really like we're done with the geometry type triangle stuff, and now we're focused more on the algebra solving for the variable stuff. Okay, so what do? We combine like terms. We talked about this stuff. That's 2H. These right here, not easy, okay? I didn't expect a lot of people to get this done correctly. We've got a positive number and a negative number. Adding integers with different signs, subtract the numbers, keep the bigger sign. You know this. So 90 minus 38, boom, borrow. That's a 10, that's a 2, 5, so it's plus 52. Wait a second. A mistake by Mr. Fessenden right there. Keep the bigger sign. I forgot about that. So there should be a negative, which seems weird. Let's add 52 to both sides. Opposite operations. Whoa, what did he do? Pause it. Think about it. Look at it. Go back over my words. Hear them again. Look at the slides that we have. Okay, see if that'll help you out. Okay. Plug things in. Combine like terms with the H's and the regular numbers. Opposite operations. Okay. Move the add subtract stuff, then the multiply divide stuff. This 2 is being multiplied by H, so let's divide both sides by 2. Yes, the fraction means division. You know this. 1 these two that's out. A little phrase we haven't heard in a little while maybe. H equals, how many times does that go in there? I'll give you a little shortcut. 16. 200 divided by 2 is 100. 32 split in half is 16. So 116 degrees. Almost done. So, questions? Anybody? Questions? Raise your hand. Email me if you have any questions. We can set up a Google Meet if we must. All right. So, this last one that we have right here. I noticed some people on the IXL struggling on this part. Okay. There'll be some more IXL today. Let's just get it done. Ask questions along the way. A lot of fun. One angle of an isosceles triangle measures 120 degrees. Which other angles could be in that triangle? Wording is kind of weird, but let's start by just drawing a triangle. Okay. I'm particular. I know that the 120 is going to look a little bit more like that. Okay. But you don't have to draw it like this. The picture is not as important as the numbers that go inside. So if this is 120, what are the other angles? Okay. So the trickiness here on one like this is that it says it's an isosceles. All right. So if it's an isosceles, I know it should have two sides that are equal and two other angles that are equal. Now, you might have thought, oh wait, this could be that angle that there's two of. 120 and 120. No, that's not possible because that would already be larger than 180. Remember, that's what we figured out, 180 degrees in a triangle. So it has to be these other two angles that are equal. Therefore, if we're trying to figure those out, it's like 120 plus, let's just say x, it's my favorite letter, plus another x equals 180. Let's pause on that maybe for a moment. Okay, we know there's three angles. We know one of them's 120. If we didn't know that the other two angles had to be equal, we couldn't solve it, okay, if it was x and y. But these are both the same degrees, so we can say x and x. Now, it's back to combining like terms type stuff. Equals 180. I know this is not easy, just watching the video, trying to do the IXL. Remember, read the explanations in the IXL, but I know a lot of times those are funky and difficult. I use opposite operations, okay? Trying to get the x by itself, so I subtracted 120 from both sides. That gets me 60. How come? Well, 18 minus 12 is 6. If you don't have that memorized, that's okay. Look at this. The 1's here, the 0's there. What's 8 minus 2? 6. So that just goes in this place. 1's cancel out. 0's stay the same. I mean, you don't need to do it that way. It's a little mental math trick, perhaps. Opposite of multiplying by 2 is dividing by 2. Do that to both sides. And all of a sudden, I squeeze this in here. X equals 30 degrees. And that should work. 30, that's 60. Plus the 120 is 180. And yeah, I'm pretty sure that's all I got for you. Check out the rest of Google Classroom and see what's on there for you. Good luck, everybody. Email me your questions, please. All right, best of luck to you.